Hello everyone, day 2 of my machine learning journey. Yesterday I worked on regression. Today we move into classification. We'll use logistic regression to predict survival on the Titanic dataset. I'll explain each step as I rerun the code I have. First, let's start with the title. We have the Titanic Classification with logistic regression and my name here using Markdown. So let's start by expanding the Jupyter notebook and we're going to explain what we have here. For the section 1, we're going to import the libraries and the data. First, we import pandas for data table, Seaborn as SNS for the data set and the plots. We're using a built-in data set. Scikit-learn for splitting pipelines, preprocessing the model and metrics, and matplotlib for visualization. Then we load the dataset for Titanic using Seaborn. Let's run this code first. As you can see here, this dataset has information like sex, age, fare, passenger class, and embarkation port. And our target column is survive, which is 0 for did not survive and 1 for survive. We can see here the different columns that we have with the head command as a preview. Section 2, features and target. In this case, we're going to do a little bit of data cleansing and we select the features that we'll be using. In this case, it's going to be sex, age, fare, class, and embarked columns or variables. These give us a mix of both numeric and categorical information. We'll set those aside on our X variable. Our target is survival, which we will call Y, or our predictor variable. As you can see here, we're going to drop some values because we do have missing data, and we're going to use drop NA, and we're going to realign them so it matches the clean data set with the log command using the X variable as an index. So let's run this code or cell. Now for our section 3, we're going to train, test, and split the data. We're going to use 80% for training and 20% for testing. This way, the model learns from one portion and we evaluate it on data that it has never seen before. We also select a random state of 42 so we can replicate the results later on if need to be. Now we run the code. Then for the next section, we're going to do preprocessing and starter pipeline. This is the most important step. We separate the numeric features, in this case, the age and the fare, and also the categorical features, in this case, sex, class, and embarked. We can see here in the code, we're selecting those features, and now we're going to jump to the transformer section. For the numeric features, we apply the standard scaler. This centers the variables and scales them so they are on a similar range. Also, logistic regression performs better with scaled inputs. For the categorical features, we're going to use OneHotEncoding. What is OneHotEncoding? In essence, we're going to transform labels or categories into ones and zeros. In this case, we're going to turn categories such as male and female into numeric values that the model can read or use and understand. Then we combine them both using a column transformer. This makes sure each feature is handled the right way. As you can see here in the code with the preprocessor, we're selecting the numeric transformers and the numeric features, and also the categorical transformers and the categorical features. Finally, we create a pipeline that first pre-processes the data and then fits it into a logistic regression model. This pipeline ensures everything is applied consistently to both the training and testing data. As you can see here in the pipeline with the fit argument with both train and Y variables. We run the cell and this is our output. Now for the predictions and metrics. For this section, we use the pipeline to make predictions on the test set, and we also calculate the probabilities of survival of each passenger. We evaluate the model with several metrics. We're going to use accuracy, the overall percentage that the model is correct, precision, when the model predicts survival, how often it's right, and recall of all the actual survivors, how many the model catches. The F1 score, which is a harmonic mean, is going to balance between the precision and recall. And the ROC-AUC curve is going to tell us how well the model separates the survivors from non-survivors across the thresholds. These metrics give us a complete picture of the model performance. For example, a high accuracy with low recall will mean that the model misses many real survivals. Now we run this code and we have our scores here. For accuracy, we have 79.72, precision 86, recall 63, F1 score 73, and the ROC-AUC curve 81. For our next section, the confusion matrix, we're gonna finally visualize the results with this matrix, and this shows us 4 numbers, which is in essence the type 1 and type 2 errors, which are the true negatives, passengers predicted as died who actually died, false positives predicted that survived but they die, false negatives predicted that they died but they survived, and true positives predicted that survived and actually survived. This confusion matrix tells us what kind of mistakes the model is making, not just how often. Now we run the cell with the code. And also to explain what's going on with the visualization, we have a figure by 6 by 4 inches. We're using a heat map for a confusion matrix, a CM. The annotation is true, so it shows its labels and the numbers. The format is D to keep the digits or not the decimals, meaning the whole numbers. The color map, we're using the blues color map, and the X-tick labels, we're going to use died and survive, and the same for the Y variable, the labels are died and survive. And we're going to label our X and Y by predicted values versus the actual, and our title, as we see here, is the confusion matrix, Titanic Logistic Regression, and again, we're going to do a show here. Let's run that. Here we go. We have 70% that are true positives, meaning that that actually pass away, and 23% that were predicted that the passenger will die, but it actually survived. And also, we have 40% of survival rate as prediction, and the actual survival rate, it's 40, and survival for 6 that actually died were 6. And that explains how our model is behaving and the results it's computing. Last but not least, we're gonna export these results to a markdown file and saving the image or the plot. And again, we're installing tabulate, printing the results to markdown using the path here that you see. And we're gonna, in essence, it's gonna save it in my GitHub repo. And there he goes. That completes day 2 of my ML journey. We built a classification pipeline with logistic regression. We applied the necessary preprocessing. We evaluated the performance of this model and visualized the errors. This is a strong foundation for understanding classification problems using logistic regression. I'll continue sharing my progress in every video in both English and Spanish. So thank you for watching. Take care.